So welcome students. In this question, you're given that cos theta, sin phi and sin theta are in geometric progression. If that is so, the roots of this equation are always equal, real, imaginary, greater than 1. So as you look at this question, you can very clearly see that this question is based on the concept of nature of roots. I hope you remember the cases that we have in that concept. So this is a time to pause the video and see whether you will be able to do this question or not. Now, so cos theta, sin phi and sin theta are in GP. What is the condition? If three numbers are in GP, then the middle number square is equal to sin square phi is equal to the first term into last term, that is cos theta times sin theta. This is the condition. Now using this condition, can you determine the signs of this? Can you determine the nature of the roots of this equation? The nature of roots of this equation depends on the discriminant of this. What is delta to the equation? B square minus 4AC, that is 4 cot square phi minus 4. 4 into 1 is 4. That is nothing but 4 times cot square theta minus 1. So your delta depends on the number cot square theta minus 1. And you have information about, cot square phi minus 1. And you have information about sin square phi. So can you make sense of how to connect these two? So we know that cot square is nothing but, you have a trigonometric identity, cosecant square phi minus cot square phi is equal to 1. So cot square phi is nothing but cosecant square phi minus 1. This is cosecant square phi minus 1. So 4 times cosecant square phi minus 2 effectively. Minus 1 becomes minus 2. And this is nothing but 1 by sin square phi. 4 times 1 by sin square phi minus 2. And is equal to 4 times 1 by sin square phi is nothing but sin theta cos theta minus 2. So that is equal to 4 times, I'll multiply and divide this with 2. Multiply and divide this with 2. You have 2 by sin 2 theta minus 2. 2 by sin 2 theta minus 2. Now this is equal to 4 times 2 cosecant 2 theta minus 2. So obviously cosecant 2 theta is greater than 1. So 2 cosecant 2 theta is greater than 2. So 2 minus 2, this is a number which is greater than 2. Minus 2 is obviously positive number. So you can say that cosecant 2 theta is also less than minus 1. But that case does not occur here because 1 by sin square theta is sin theta cos theta. So sin 2 theta is positive here. Because sin theta cos theta is sin square phi. This number is positive. So 2 sin theta cos theta is also positive. So cosecant 2 theta is also positive. Hence you have 2 cosecant 2 theta greater than 2. So this is a number which is positive. Hence the roots are real. Option B is the right answer. Thank you.